multiply numbers if they are in scientific notation. Up to this point, we've divided, we've added, we've subtracted. Now, for everything we've done, we have had a way to check. When we divided, we were able to break out the numbers in standard form, we simplified, and we were able to find our answer. When we added and subtracted, an option was to break the numbers out into standard form and do the calculation to kind of check your answer. Still coming back to the idea that we want to do the operations in scientific notation. That is the learning target for 8th grade. Now, if you're talking about multiplying numbers, it may not be that helpful to break the numbers out in standard form and multiply them. Think about breaking a really large number out and how difficult it could be to multiply. There's another way that we can kind of check and make sure that we're on the right track. And that method would be to estimate. So we can actually round these numbers and estimate them to do a quick multiplication calculation. How could we round 5.78? What would be like our nearest whole number? 6. We could round this for now to be about 6 times 10 to the 5th. How about 0.0402? Could we round that to, I don't know, like the nearest hundredth? 0.0, you're saying 0.05. You could do 0.04, and it's really close to 400ths. That would be an option. And think about why you would estimate. Are there other ways that we could round those numbers? Did we have to round this to 6?
No.
No, what else could it have been rounded to?
5.
5.8. Earlier today, someone said 5.75, maybe. Depends on like how you like to do your calculations. How about 0.0402? Joe already said you could have done 0.05. We obviously did 0.04. Is there only one correct way to estimate or round? No, and that's important because if you use this as a strategy to make sure that you're doing multiplication right, the person next to you might estimate a different way. So if you are working together and you're comparing answers or even comparing your estimates, that might be why you come up with a different number. It doesn't mean you're wrong. It doesn't mean the person next to you is wrong. Everybody estimates a different way. Now, if we estimate this, we have 2 options. We could estimate this and put them in standard form. So we could do 6 times 10 to the 5th is what number broken out? 600,000. We could do that. What is 600,000 times 0.04? What's 6 times 4? 24. So if 6 times 4 is 24, then 600,000 times 24 should be what?
0.02.
Now our answer here is not really 2,400,000. We would need to bring back in our decimal places to have 24,000 if you decided to break it out. You also had the option of doing this estimate in scientific notation. 6 times 10 to the 5th times, this number in scientific notation is what? What's the exponent? -2. Yeah. We could have done it this way. Still, we would have gotten 24,000.
Question.
Yes.
So, like, what's the way that you did a negative exponent? If you were to write the... No.
If it comes back, yes. We're actually going to do one of the, we're going to do this and this actual
Because I
problem
remember the
in
thing
scientific notation.
has to be between 1 and 10, right?
For our if we have the number properly written in scientific notation, yes.
Okay.
So now we estimated this, and we think our number is going to be around 24,000. So keep that estimate nearby. Have it written down somewhere, because that's going to be how we're going to check it. If we do this calculation and it turns out that we get like 893 million, we probably made a mistake somewhere. So to actually calculate this number, and this is the example that you should have in your notes so that when you look back at an example, this is it. We want to write 0.0402 in scientific notation. Just looking at that number, what do you know about the exponent? It's going to be a negative. Why is it going to be a negative exponent? Say it. Okay, so You are correct. And we'll explain that in a couple different ways. If I have this number in scientific notation, what is my first number, that initial number here? 4.02. So you can look at this two ways. If the number that I'm starting with to get this final number is 4.02, what do I have to do in order to get that? My exponent, yep, I would be dividing by power of 10 two times, representing a negative exponent. But there's another reason why, just looking at this number, I can know that it would be a negative exponent. Even though I may not know what exponent, I can determine just by looking that no matter what will have a negative exponent. Why? Because that number is a super small number. It's between 0 and 1. And we know that numbers represented between 0 and 1 have negative exponents. Now that number's not really super, super small, but you get the point. So now we have this. Oh my God, don't look. Looks So this is our multiplication problem. And let's talk about strategies to multiply. Excuse me. Both of these numbers are in scientific notation. How would you multiply? Like, what do you think when you see these and think about multiplying? How would you multiply? Do I need the parentheses? Not really. Is this the same problem? Yeah, I'm just multiplying 5.78 times 10 times 10 times 10 times 10 times 10 times 4.02 times 1 over 10 times 1 over 10. Is there something I can do to this calculation to maybe make it a little bit easier and visual for me? What? What do you notice when you multiply? What do you see? Different exponents. You do. What else do you see? Okay, we have two numbers that are decimals, absolutely. What else do you see? Same base. You have numbers with the same base. What do we know about numbers with the same base? If I'm going to multiply. I can add the exponents together. So take a look here at what we did. We can actually use the associative property and change the grouping around here. And what that does is it kind of shows us a few things. First, this is the division property of exponents. The division property tells us that if we have the same base, what can we do with our exponent? If we have the same base, what would that be? 10 to what? If I'm multiplying with the same base, 10 to the third. Because I can add together 5 and a negative 2. And what kind of numbers are these? They're decimals to the hundredth. Okay? Now that is something that you have learned how to do before. And not an 8th grade standard, whether you learned it in 5th grade or 6th grade. It has been a while since you've multiplied numbers to the nearest hundredth, like to a hundredth decimal place. But it still is something that you've learned before. So with so many things that we do, and you should have everything on this page written down to see why we're grouping the way we are. With everything that we do, we try to find a connection to something you already know. We're taking a topic that you haven't done yet, multiplying numbers in scientific notation, and we're going to try to look at the problems a little bit differently to connect them to things that you've learned before. The division property of exponents you learned a couple weeks ago. I'm sorry, this is not division, so I apologize. Not really sure where my mind is. That's the product properties from multiplying. My bad. If we multiply numbers with the same base, we can add our exponents. That's something we learned about 2 weeks ago. The first two numbers there, if you're multiplying 5.78 times 4.02, that's something that you've done before. Even if it's not something you're strong with or something you've done in a while, it is still something you have learned in the past. How would I multiply that? Now, everyone has potentially a different strategy for multiplying. When you learned how to multiply, It depends on, honestly, the time at which you came through school. There was a period of time where lattice was taught in elementary school. That was a really big thing. There was a time where the standard algorithm for multiplication was taught, which is how I learned it, which is how I would multiply. There's some Japanese methods on YouTube that are floating around. There's a lot of ways that you could multiply. At this level in your mathematical career, we're not changing the way you multiply. If you don't have a strategy and you really needed assistance with a way that works, I can assist you. But if you do multiplication a certain way, we're not going to change that. And that's something that you would have done prior to now.
How come, like, I know that when I was younger, my mom can help me with my math because they didn't do it the same, like she didn't know how we were doing it.
Okay.
And so I'm like, why are there different, like, ways?
So the changes through time really, it depends on, first of all, it depends on where you live. Different schools teach in different ways. But right now, a lot of the way that we do math, it's meant to be a little bit more mental. For example, if you had to learn, and this is a little bit of a tangent, so you don't have to write this. If you were learning right now in elementary school how to add like 93 plus 17, when you learned that, you would have learned to line up your place values.
Yeah.
Right? And then you would have said 0, 1, and then 110. Now it's taught differently. Now they're trying to teach students to group. Meaning if this number gets 3 smaller, this number gets 3 smaller, and you can do that in your head. Wait, did I do that right? 93 and 17. That was subtraction, my bad. You could add 93 plus 10 is 103. 103 plus 7 is 110. Like the grouping is different. I'm sorry, I just said it as a So 93 plus 10 you could do in your head, and then add the 7. So instead of adding 17, add 10, then add 7. The grouping is to do it mentally. Subtraction is actually where the method for subtraction. Instead, you would have been taught to line it up. So that's an 8, this becomes a 13, so that's a 6 and a 7. Now, if you're talking about the difference between numbers, the difference between 93 and 17 is the same as the difference between 90 and 14, because that's 3 less and that's 3 less, so you could do that in your head. A lot of the shift is to do mental math. That is a shift. I'm sorry?
No. Like, how did you learn? Like, yeah, like how do you know what's going on now?
Well, just like in teaching and stuff, we always go over like strategies, like why things are taught, and to teach middle school successfully, I do need to stay up with how they teach in elementary school, because those students that come up, like my first year as a teacher, lattice was huge. Like my 7th graders, because I started here as 7th grade, they all came in like doing Latin, and I remember one day walking around being like, what is that? They had like a picture, it was like this and this, and
Yeah.
I had no idea. And I learned very quickly that you have to kind of know when students come up to you, especially in a time where 6th grade was in the building for the first time. So if you were a 7th grade teacher, they had never even been in your building. You have to really know, like, how is it taught before they get here? Because if you're confused about something, I have to know, like, how you learned it so that I can help teach it. Sorry, that was such a tangent.
I remember in 6th grade there was a certain way that we did division in elementary school, and then when we came, they made us change it.
Right, and that, unfortunately, different systems of math come through, and that happens sometimes. There's also times where what you're expected to learn in every grade changes, and there was a period of time, my first year here, the actual learning standards had changed. And imagine this, something that was normally taught in 7th grade, that year when the kids came into 7th, now is taught in 6th grade, so they never learned it. So then all of a sudden when they went to 8th grade, the teachers were like, why don't you know how to do this? And the kids were like, we never learned it. So as teachers, we went back and we were like, oh my goodness, they entered 7th grade in that year where that one topic legitimately went from being taught in 7th to being taught in 6th, so it skipped them. So that happens too. And that's you know, the behind the scenes in terms of teaching, like we want to constantly stay up on that sort of stuff so that that doesn't happen. Because that did happen before. So coming back to this, if anyone watches this video, they're going to be like, what are they talking about? So our property of exponents for multiplication tells us if we have the same base, we can add the exponents together. If you needed to see that broken out, that is actually 10 times 10 times 10 times 10 times 10 times 1 over 10 times 1/10. And if these are big ones, so we're left with 10 to the third. If you needed to see it, when in doubt, break it out, right? For 5.78 times 4.02, you would actually multiply this. There's only so long we can avoid it. If we multiply here, standard multiplication algorithm is how I learned. 2 times 8, we would have 16. 7 times 2 is 14, but we have 1. So we have this, 11. I never did that before I taught. My students were like, no, put the X, it's so easy, it helps you remember place value. So 0 times 8 is 0, and 0, and 0. 4 times 8 is 32. 4 times 7 is 28, but that becomes 31. And then 23. So what do we have? 23, 23, 56. But I'm not done because I did not multiply 578 times 402. We multiply 5.78 times 4.02. So I need to bring back in these 4 place values. So 23.2356 times 10 to the third. Am I done?
No.
No, I'm not. That's not in proper scientific notation. What could I do to get it there? Between 1 and 10, that would be 2.32356 times 10 to the fourth. Good, Ibrahima. Now take a look back at our estimate. Were we close? Is that a reasonable estimate?
Yes.
Absolutely. Yeah. No. 2.32356 times 10 to the fourth is very close to 2.4 times 10 to the fourth. So think about, why would we estimate? Imagine we did this whole calculation, and this is what we came up with. What would you say if that was our actual and this was our estimate? What would you think?
I would say 2 to the third power is 8, so I was close.
You try to find some way to justify it, but if you see that your numbers are that far off, then there's a mistake somewhere, right? But because our numbers are relatively close, we can assume safely that we didn't make a mistake. Now the estimation, you do not have to estimate. It's just an option for you, and it's really a way to check. We try, at least I try, to provide a way for you to check your work no matter what. If you're solving an equation and you get x equals 7, you can always take the 7 and plug it back in to see that it works. So this would be the check for multiplying. So now I'm going to give you a problem. And what we're talking about right now is the idea of estimation should be fast, right? It shouldn't take too long, like 30 seconds. For example, 3.9 times 10 to the third times 2.2 times 10 to the fourth. This is about 4, this is about 2, 4 times 2 is 8, and then I can add my exponents, 3 and 4 is 7, so 8 times 10 is 7. But that could take you like 30 seconds, maybe. Okay? So I'm going to give you a problem. I'm going to write it on the board, and you, as fast as you can, are going to estimate what the answer would be. We're not talking actual. We're talking estimate. Okay, so I'm going to put 30 seconds up. If you're group 3 on iReady, please transition over at this time. So I'm going to put a problem up on the board, and you are going to estimate. Just like this example said, 3.9 is about 4, 2.2 is about 2, and get your estimation. That in 30 seconds. You can do this in your notebook. You don't have to show it. You don't have to hold it up. Okay? 30 seconds. Let's see. When you write it, and you're going to do the little calculation, that's fine. As soon as you get it and you have your estimation, for example, here we had an estimate of 8 times 10 to the 7. Hand up in the air. We want to see if all of you can estimate it in 30 seconds. Okay? So now, close your eyes, because I'm putting it on the board. I don't want you to see it.
Open your eyes.
Everybody's eyes closed. If you're on iReady, your eyes should be open, but everybody else's eyes closed. Ready? Go. Estimate 30 seconds. Hand up when you've got it. Just an estimate, you're not doing actual. 15, 14, 13, 12, 11, 10, 7, 6, 5, 4, 3, 2, 1. Pencil down, Kate. Good. Right. Okay. So what do we think about what? 3. About 3 times 10 to the second times 3. 3 times 10 to the third, which would give us what? 6. About 9. About 9 times 10 to the third. Now, if we needed this done quickly, right, real quick, 2.8 times 3.1, we have 8, we have 2, we have 24, we have 8, 8.68. Sorry, that's sloppy. So 8.68 times 10 to the 5th is the actual answer. We were about, I said about 9 times 10 to the 5th. So we were close. Right, you were close. Okay, let's do one more, but now this is the last one we're gonna do. I'm gonna put up 25 seconds. Really make it work for it. All right, close your eyes. I'm making this one up. Okay, so close your eyes. Ready? Go. David, you're still writing your hands up. 5, 4, 3, 2, 1. Oh, you guys are bad. Okay, so about what? Approximately. About 4 times 10 to the third times 5 times 10 to the negative 6 would equal what? About 20 times 10 to the negative third. Now that is not in proper scientific notation, but it's okay because we would put it in proper. Now if we had to multiply it, we'd have 6, we'd have 12, we'd have 10, we'd have 21. So 21.26 times 10 to the, yeah, we're really close. Now, this is not the only way, right? If you take an exam and you're multiplying, I don't expect you to just estimate and it's done. This is what you're doing to check. And the purpose of that little exercise is to show you that it doesn't take much to estimate what the answer should be. In about 25 seconds, you can estimate and give yourself a really good indication of about where your real answer should be. The reason you would do that, if you're way off, it's your red flag, right? That's how you can check it. Okay? You're going to try one. Just one. Okay? And you could do this with some friends. I'm actually going to pause the video once we start it. The world's thinnest computer chip is 7.5 times 10 to the negative third millimeters thick. What would be the height of a stack of 3 times 10 to the 9th chips? If you need to estimate it, you can. If you don't, you could just calculate. Let's take about 3 minutes and find your value. I'm going to start this, but then pause the video.